You have the advantage of having your calculator. So as long as you understand the concept, like we did the standard deviation, that big long chart, we did it once or twice. As long as you understand where things are coming from, I'm fine with the calculator. In college, most of the time you'll have software packages, and I've helped different college kids, and they do these ANOVA. They list some of them in the book. They're like, I know the Mount has ANOVA, I think it's called. And what it is you input your information, and it does everything for you and spits it back out on a piece of paper. So you really don't have to do much else but know where to input it and know what you're looking for when they bring it back. But I do want you to understand the concept of that black box thing. Like, where's it going? What am I doing with this once you put it in your calculator? So the main thing that I want us to address is this piece right here, the mean. We can find the mean of your data set. And the mean, when they do this on their data set, and I'm going to show you in 1 second, we're going to walk through this. We're going to take your probability inventory for your passive-aggressive one, and remember it was based on 100, the one you just did yesterday, the passive-aggressive traits. It was based off of 100, so we looked at the probability. Now, to find your mean down here, this is going to be your mean. They multiply this times this. Now, I want you to think for a second. When we did your frequency, here was your frequency in here. And whatever the frequencies were. Oh, maybe this wasn't based on 100%. Whatever the frequencies were. We would do this times this, add them all up, and divide them. Well, the thing is now, when I add them all up, they add up to 1. So I don't have to worry about dividing it by 1. I'm basically just multiplying this and this now. See it? You know how you normally do your frequencies? Let me revert back to this page for 1 second. Oh, we did it. We did our own. Let me just pull up this frequency one. Passive aggressive. These were the frequencies. It didn't add up to. It added up to 150. Now, how would you normally find a mean with the frequency distribution? Yes, we plug it into our calculator. But if I was going to do this, I would do this times this, this times this, this times this. I would add these all up, get my sum of all of these guys, and divide it by my 150. Wouldn't that give me my mean of a frequency distribution? Now, watch what happens. They convert this to the decimals because they divided each one by 150. So instead of dividing it at the end, they divided each one. So that now these all add up to 1. So technically, if I multiply this times this, I've already divided by the 150. So all I have to do is multiply this times this and add them up. Because even if I divide it by the total, I'm only dividing by 1. So to get your mean of a probability distribution, you could take your x times your p of x, and then add these pieces up. And this total is your mean. Now, I just want you to see how this happens. Do you see it? I need you to realize what happens in a distribution. We multiply the pieces, we add them up, we divide by how many there are. Instead of doing it at the end, each one was done individually, divided by 150, divided by 150. That's how you get your p of x. When you add these up, they're 1. Now, here's what happens. You guys have a calculator handy? All right. Whoever has a calculator handy. Okay, let's do Daniel. Daniel versus Leslie. Daniel, I want you to put L1, L2. Okay? And I want you to find me the mean and the standard deviation. Leslie, I want you to put L1, L2. And I want you to find me the mean and the standard deviation. And we're going to see if in fact they are the same thing. And if our mean turns out to be 2.94. One bear stat, don't forget the L1, L2. Normally, yes, we put it in our calculator, L1, L2. And on a frequency distribution, I just want you to think the process through. Multiply, multiply, add them all up, divide by 150. So let's just do it differently, in a different order. Divide this by 150 first, then multiply them, add them all up. It works the same way. You're going to get the same results. So Daniel, what did you get for your mean? Okay, L2, you're going to put this column in. 24, 33, 42, 30, 21. So Leslie, what did you get for your mean?
2.94.
Okay, what did you get for your sample standard deviation?
1.27.
Your sample?
No, that one was 0.
That one was blank,
Yeah.
right? That one is blank. And I'll explain that in a second. That one should be blank. 1.27 should be your population. Now, when Daniel comes up.
I got 2.94 for the mean too.
Ah, see that? What'd you get for your SX?
1.27.
1.27. What'd you get for your population one?
1.27.
1.27. Now, doesn't matter which way we go, because remember, whether you divide by 150 at the end or you divide each individual one by 150, you're still doing the same process. What happens here is this. The sum when you add these down is divided by 150. Think back to when we did standard deviations. We took the sum of those things, the squares, we divided by n. When we did your sample, we divided by n minus 1 to get your SX, right? Now, when the numbers are large, they're a little closer together anyway, because it's not a big difference between dividing by 150 or 149. However, when you come to this part, this is going to do the same thing. It's going to add up the total. It's going to divide by n, which n is now 1. The sample one says n minus 1. Oh, it can't do n minus 1. It can't do 1 minus 1. It can do 1 minus 1. It can't divide by 0. So, in this case, you do not get a sample standard deviation because your total is 1. If you subtract 1, you can't divide by 0. But it doesn't matter which one we put in, whether it's the original x's and the original frequency, or the x and the p of x. Both of them give us the same results, don't they? So that's what I want you to see from this. I really would like you to think through why. Because if we add this and divide through at the end, it's the same as if I divide each one and then add to it. Okay? It's going to be the same exact thing. So this is how we get our mean, our standard deviation, and our variance is the same thing. We just like we used to. We go to your VARs, we go to statistics, we take out your standard deviation, and we square it. We do the same exact thing to get your variance. And we're going to use your calculator for this. I like you to see this once or twice, but I like you to then be able to use your calculator. So basically, that is it. They do go through, if you take a look at 195, page 195, they do go through the whole thing of how to find your variance. They take that whole thing and then they divide it out. Do I need you to do that? No. For us, as long as you kind of remember how we did the standard deviation, find the mean, find the difference of the difference, square them, add them up, divide by n, square root. Now, if you just think it out, I'm okay with that. So are you good with this? All right. So now, in example 5, example try it 5. This one added up to 100. So we made our decimals very nice. Okay? Now, again, you could put L1, L2, because in this case, maybe this one's easier to see. if I multiply this out, I multiply all of these across because I have a frequency. I add them all up, I divide by 100. Okay? Versus divide by 100 and add them all up. And then just multiply it. Because when they add up your decimals, they're 1. So it doesn't really matter with the 1. The only difference is if you do this in your calculator, you do not get a sample standard deviation. Because 1 minus 1 is 0. You can't divide by 0. If you do this part right here, and you multiply this all the way across, and let's do that together. I multiply these two columns. 0. Good. 0.3. Good. Point what? 0.63. Good. 0.36. 0.5. 0.48. 0.14. Now, add those all up. That is actually your mean. That's your mean. And then try. Pick one of them. Pick one combination. Either the green L1, L2 or the black L1, L2. And put it in your L1, L2. And see if you come up with the same mean when we add all these up. So what'd you get? 2.6?
Yeah.
2.6. So when you put this in your L1, L2, you should also get a 2.6. Now if we wanted to do your standard deviation, we would have to do the differences of the x, we'd have to square it, we'd have to go through the whole thing. But since you're going to do it on your calculator, you can find everything right there. Okay? It's as simple as that. I mean, we've done these before, and all I want you to do is to try to understand why this is able to add these all up and come out to be our mean. Because tomorrow, we're going to look at this in terms of expected value as well. So today, I just want you to get down your standard deviation, your mean, and your variance. Good? Okay. Here's your class assignment. I kind of grouped it with yesterday's. So I wanted just to finish this. Okay? There's your class assignment.